We ask a simple question, one that echoes through centuries of stargazing. What is the largest star? But largest is a slippery word. Are we talking about the most massive, the most luminous, or the one with the greatest sheer physical size? Each metric tells a different story. Today, we chase radius, the most intuitive measure of size, how far a star's surface stretches into the void. The candidates for this cosmic crown are staggering, names that sound like catalog entries but represent true titans: UY Scuti, VY Canis Majoris, and the current frontrunner, Stephenson 2-18. These are the hypergiants, impossibly bloated, fundamentally unstable, and shedding their own atmospheres like smoke in the wind. Their scale defies easy comprehension. If one were parked where our sun sits, its surface would engulf the orbits of Mercury, Venus, Earth, Mars, and Jupiter. Some would even swallow Saturn's distant path. But how do you measure such a beast? Pinning down the size of a fuzzy, pulsing surface thousands of light years away is a treacherous task. Everything starts with distance. It must be nailed down first, because any error there magnifies all others. The Gaia Space Observatory's parallax measurements set the cosmic ruler. Then we must account for the veil of interstellar dust that dims and reddens the starlight, an effect called extinction that we must carefully unmask. The star's own light holds clues. Spectra reveal its surface temperature, and luminosity then ties its intrinsic brightness to its size and heat. For the most direct look, astronomers use interferometers, which stitch together the light from multiple telescopes to act as one giant eye, sharp enough to resolve the actual disks of stars across unimaginable space. We trace the faint glow of molecular shells, the shadows of dusty plumes, and the shock-bright arcs of gas they've already cast off. With each new observation, the numbers settle, and then they shift, as these colossal stars literally breathe and boil. UY Scuti, it was once crowned the champion, but when its distance was revised by Gaia, its calculated radius shrank dramatically. VY Canis Majoris, it's a complex storm of knots and clumps, making it nearly impossible to define where the star ends and its chaotic surroundings begin. Which brings us to Stephenson 2-18. It now leads many lists, an immense red hypergiant of breathtaking proportions. The most generous estimates place its radius around 2,150 times that of our Sun, give or take hundreds. An uncertain giant. And its volume? If it were a hollow sphere, over 10 billion suns could fit comfortably inside. It lives nearly 20,000 light-years away, and its light must fight through a thick curtain of heavy dust in a packed, ancient star cluster. For all its incredible sprawl, its mass is modest, perhaps only 10 to 20 times our Sun's. Its outer layers puffed up by intense radiation and astonishingly low surface gravity. Furious stellar winds roar from its surface. The star peels off itself in shimmering curtains of gas and dust. This is final act living for a massive star, a phase that is short, violent, and profoundly wasteful. Soon, on an astronomical timescale, its core will run out of fuel. Gravity will win. It must collapse and detonate. A supernova of unimaginable power will rewrite its entire cosmic neighborhood. Heavy elements, forged in its heart and in the explosion itself, will fly out to seed new generations of stars and planets. So, being the largest today is just a snapshot in time. Tomorrow, the crown can, and will, pass to another. It's a title in constant flux, because our measurements sharpen, and the giants themselves evolve in real time. So, is this the largest star in the universe? For now, Stephenson 2-18 likely wears that ring, uncertainty and all, and that uncertainty is the point. It's at these cosmic edges where our understanding grows the fastest. Look up. The stars are not just lights, they are experiments, running at a scale we can barely imagine. Our sun, the center of our world, is beautifully ordinary. It's the existence of these extremes that keeps the cosmic story honest and humbling. The universe isn't just big, it's dynamic, it's busy. And for a fleeting moment, it is briefly, impossibly, colossal. So we breathe. We look again. And we remember the crown is always provisional.